Alright guys, so in 12.3 we're going to talk about what's called the twisted Sierpinski gasket, which really shouldn't take us too long to discuss. We'll just kind of look at some of the cool things that it's been used to do. And we really won't do a formal construction of this by hand. It's really something that works best to let a computer generator kind of do. It's still kind of interesting to look at. So with the twisted Sierpinski, we're going to start it kind of the exact same way. We're going to start with a seed triangle, which is going to, let's just call it ABC here, and it's shaded the same as it would have been for the regular Sierpinski gasket or Sierpinski triangle. And then let's see kind of what we do. So the next step is we cut out the middle triangle, just like we would have in a regular Sierpinski triangle. We cut out that one which has the corners or the vertices at the midpoints of each of the sides. So again, it looks something kind of like this. The next move though is what's different, and we're going to call this the twist, which is that each of those midpoints, which you can see that those are labeled M, N, and L on this diagram. So again, I'll circle those for us. So here were the original midpoints, M, N, and L. They're going to be moved in a random direction and a random length in each of the cases. So N was moved to this new spot in prime, L was moved to this spot, L prime, and M was moved to this spot, M prime. Now A, B, and C are not going to change, but those other vertices are. So notice that A, B, and C are still in their normal position. In fact, you could even, if you had a way of drawing a straight line, which is kind of hard to do on the computer here, but you would be able to see that ABC's the original triangle really has not changed at all, but M, N, and L have changed the way the edges look because of the twist that happened. And again, you can kind of see how it was just kind of deformed almost in that step. But really from there, we continue that process. So for convenience, we'll use the terminology TSG to describe the combination of your two moves, which are the cut and then also the twist. So again, this procedure, you cut out that triangle with your midpoints and then twist the triangle by moving each of those midpoints a small amount, a small random amount in a random direction. So again, pretty easy kind of to think and see what's going on. Obviously, you'll start with your seed triangle. Step one is we twist, and then as we continue in step two, we just repeat the process. So for each of those triangles that we had, we go ahead and find the midpoints for each of those, remove that inner triangle, and then go ahead and move each of the midpoints a little bit. And again, it creates this kind of twist. And then you would just continue to do that. So you continue to apply that same procedure, and eventually you'll get to a triangle that looks something kind of like this, which is kind of interesting. Even just this basic form, it's kind of cool. One of the things that we'll talk about is that they've actually used this twisted Sierpinski gasket to render images of snow-covered mountains, so to create those for different effects. In fact, here's an example of what that is. So the top photograph is real. The bottom photograph actually is CGI. So it's a computer-generated image, which actually was created using a lot of the same procedures that we just saw for the twisted Sierpinski gasket in order to get the mountains to look mostly realistic. Pretty cool. So again, here was your replacement rule. So you start with the original C triangle. The replacement rule is whenever you see a shaded triangle, you apply that procedure TSG, which was to remove the inner triangle and then to move each of your midpoints in order to twist your triangle. But that's really it. Again, it's a pretty simple construction when you think about it. Now, let's talk about the different types of self-similarities, because obviously it's going to be slightly different from what we would have seen in our Coke snowflake as well as our regular Sierpinski triangle. And the twisted Sierpinski gasket or triangle, we still have infinite and we still have universal self-similarity. But because of the randomness that we have in your twisting process, that self-similarity is only going to be approximate. It's not going to be exact. So you can still infinite, you can still do it in an infinite number of times. So if we wanted to keep going, and zooming in, we could keep zooming in and further. But Also, universal self-similarity, so no matter where you decided to look at it on this particular image, you would still have kind of that universal self-similarity that it looks the same no matter where you look. But the one difference is that now it's only going to be an approximate self-similarity. So notice that in each of these cases, the triangle that we are looking at does differ slightly from one image to the next. In other words, this triangle is slightly different from this one and slightly different from this one. They have an approximate self-similarity, but not the exact self-similarity that we saw with the Koch snowflake and with the regular Sierpinski gasket. And it's that approximate self-similarity that actually gives us a really good picture, a really good shape, a natural look that the original Sierpinski gasket would. So this is why the twisted Sierpinski that randomness gives an important element to creating imitations of those natural-looking shapes. Remember when we talked about the cauliflower, we talked about that it did have the universal self-similarity, it did have the infinite self-similarity, but it was lacking the exact self-similarity. It had approximate self-similarity, but that's kind of the thing about nature and making stuff look realistic, is that it really shouldn't look exact. Not everything is cookie cutter. So that's kind of the one advantage that the twisted Sierpinski has over the regular Sierpinski, is that it can be more useful for things like generating these images that you can see on this slide, one of which actually is a real image, the other being a computer generated one. If you are wanting to know which is which, I will leave it up to you to decide which one you think is real and which one you think is generated. Guys, that is it for Twisted Sierpinski. Pretty short section of notes. Hopefully still one that was enjoyable for you. And we will talk about what's called the Mandelbrot set in our next section. Until then, have a great rest of your day.